Good evening, everyone. So let's start today's session.
Good evening, sir.
I am audible, right?
Yes, sir. Yes, sir. Sure.
Okay, thank you.
You're audible.
Okay, so last time we have already done AutoDock docking docking part, means preparation of receptor and ligand. Now this time we will be dealing with result analysis. So I guess in this session, whoever is present have already done the docking part and have got some screen or results like this. So for the analysis part, after the docking we might have got a few files. Uh, one of one of the is result screen, and another we have might have got uh, out some out file, or may not be, maybe we would you would have not got that. So basically my motto was to make you learn how you can start docking. This time I will start docking, uh, show a demo docking just for revision purpose. Here I will go in the terminal, and from the terminal I am in the same directory, like that, I am on the terminal. So you can see that this path, means this folder path, is same as this directory path. Fine. So and here I can see all the files. To list the files in command line, I will use dir command. So my files in the directory and in that same folder, I can confirm that I am on the same folder. So this lib file is this, and receptor is this, and prepared config.txt is here. So like that, and I can confirm. Now for the docking, what we did in the earlier sessions, just we just use VINA, and for specified the receptor by using dash dash receptor. And here I have renamed my receptor name in short, so that I can easily type it, and then dash dash ligand, and here I can use ligand, and now I will specify config.txt. So now I can start the docking part. Fine. So here I will be getting some output or results in the same directory. I guess everyone was able to perform docking till here. I will get a result in few seconds or maybe. And one question you might be having, that what is this warning, like search space volume is greater than 27,000 Armstrong. Basically, AutoDock VINA is for virtual screening. Virtual screening means for quickly finding a drug which can interact with your receptor, or multiple receptors which can interact with a single drug. So for that purpose, single site is defined, means we try to find some homologous molecules which have similar characteristic that of molecule already interacting with the receptor. So like we might have we already know about antagonist, agonist. So like that, we try to find some similar molecules, and for that we need to specify a particular site on the receptor. So that space is very small, means for a drug molecule it is less than 27,000. That's why this warning is appearing here. Everyone has already performed the docking part, but they you were not able to copy this result uh, in your result file. So for that, please focus here, that while you are doing anything on the command line, you should follow these options. I am changing to my directory. So whatever comes in the command line means here in the command line or output, how you can copy that to copy to a file directly, because after the docking part you are getting all the results here in the screen, and you are not able to copy that to means you have to either or copy it or take a screenshot to note those results. So for that there is a one operator which helps us to get the content of this screen in a file. So what I am going to do here, like I want to, for example, I am using dir command which lists all the directories, but I want all this content or output of this dir command in a file. So for that I will do I am using slash operator using dir. Operator is angle bracket, which is uh, greater than angle bracket, greater than symbol or angle bracket. So whatever is will be the output, that will be sent to a file which I am going to provide the name. Here I will be sample.txt, so it will be saved in sample.txt. You can see that sample.txt is created here. Fine, I will open it with notepad to visualize what content it has. So basically I can view the content. So the content which was here uh, means when I didn't use that operator, this simple content after applying operator was sent to the file name which I have given. So what I have done here, I will repeat the command once again. Command and right angle space, then right angle bracket and space, file name is whatever file name you want to save, like pdbqt or text file or whatever file you want to save. Similarly, when you will be using OpenWebel in command line for multiple molecules, this operator will help you to send the content of this command to this file. So that will be required. Means there will be many cases where you will be needing such kind of operations. So here my docking is completed, but I have to copy this whole content to analyze. So either I can right click on it, and if select it and right click, if I am clicking right, then it will be directly copied to your clipboard. It will not show any prompt or anything. So it is already copied, and I don't need this simple.txt file. I can paste here for demonstration purpose. So I can use file menu or edit option to paste that content, but in the command line you might not get any right option. So it will directly either copy if you have already selected, and if you right click on it, it will paste whatever you have already selected. So for example, I am selecting this number and copying it. It has been copied. I pressed just a right click. So if I want to paste here, I will just press right click and it will be directly pasted. So means you need to notice this, because sometimes we are confused that this is not working. So this is the result, and here if I would have used after this whole command, this vina config, if I would have used space and the right symbol, like I have already demonstrated this right angle bracket to result.log or some other file name, so that content will be directly sent to result.log file. You might be seeing result.log file here. It is also text file. I have just not given any .txt extension. So the progress will be directed here. Means you will not see the progress in the command line, like here, if this command is running, means this command is running, but when earlier I ran it, you were seeing all these things, but now those the content which were displayed by VINA is now directed to this result of log file. So whatever progress is made, that will be logged here, and you can visualize it step by step. So after some time it will be upgraded to this step, performing docking, like that. So basically, to save your file directly to file, you need to use this angle bracket and provide your file name. So this is additional thing I am adding after docking part, this angle bracket and this whole file name. And remember that you should not provide a space in your file name. If you are using space, then you should use inverted comma. So this will be logged, and already I have my results in sample.txt here. Now I am going to explain this table. So here it was earlier processing that it has done 100% processing, and after that it gave us these tables. Actually, in the tables, in the from different parameters, I have got 10 options. So I will be linking all those things, but here first you should know what is this these columns about. So if this first column, that is mode, so it is giving you means how ligand has been docked, means how ligand has been transformed, and these numbers are telling the positions or conformations of ligand which have been docked, means analyzed for their docking possibilities. So it has suggested me 10 poses, and this is energy, means it is internally calculating all the energies here. And for the first pose, the energy is minus 6.186, means if there is a negative energy, that means system is stable, because from thermodynamics classes you might have already known all those things. So lower the energy means the more negative value, means more affinity the ligand is having towards the receptor. That's okay. Now second is the distance from best mode. So these are two columns. uh, so this is first mode is the best mode, and it will have value 0, and other modes are like lower bound and upper bound. So lower bound means minimum root mean square deviation, RMSD. Full form of RMSD is root mean square deviation. uh, Deviation. So what is this? If you consider two atoms, then distance between them is some d distance they are having. So if we consider one more atom, then there will be some d2 distance between them, and here it is d1. So if we want to calculate these two distance, either we can tell that these atoms are d1 and d2 distance apart. But when the system has more atoms, we can't list out all the distances. So there we use root. First we find out the mean. First we find out the square of these distances, then find out the mean, and then get a root value of them. So here for these distances, means for these two poses, it has found some distance of 36.25 Armstrong distance. So means these two poses are at this distance, and third pose is more far away. And if we want to know means displacement from one second post to third post, we can subtract this, but we really don't need to analyze this. This just tells that if a receptor has multiple sites, like if I'm considering this random shape, and if we talk about this site and this site and this site, so if we have some molecule in at this place, this blue molecule, so from here the from here to here, that RMSD value will be very different, means very higher. But if we consider these two places, it will be lower. And if we consider distance between these two points, so it will be lower. So this just basically tells us that uh, two poses are means by comparing these distances, we can tell how far uh, the other poses are being docked. So other poses, if other poses are far from here, we may have some significant new site. But if they all are docking at the same site, like here, so we might select any random shape, and based on their interaction. So means I am going to explain the selection criteria for out of these 10 poses. So but basically you just need to understand that what are these values. This first column is energy, and these columns are means distance from this particular first pose, which has been told best by the AutoDock VINA. So and lastly I started here, and here it is had been docked in two lines, but I redirected the output in the file, so I can see result dot pdbqt in another file. So like that you can redirect. And going further, now I will be opening. Okay, so I guess there is maybe some problem. I need to reopen result.txt, result.log file. I'm opening it again. Maybe okay, so that result is docked again. I have done 2 times docking. One more point I'm going to describe here. You will be seeing some differences here, maybe. Here you can see that there are two results, means earlier while demonstration I have performed docking 2 times. First time you are seeing results, this result, and then I logged this result. These two results are same. But one thing you should remember, that any program which are going to perform docking is going to perform docking in on random basis, means uh, uh, it will take consider a receptor. Suppose this is receptor, and it will make it rigid. It will consider that this is a lock, and it is not going to move, and it will take a ligand as key, and it will try to fit in random order. Means if we have some ligand in this shape, it will rotate it or twist it, and based on that it will try to fix at any point, and this will be totally random. And to control this, there are some options. I'm going to look for the VINA options. Here we will be seeing one option which helps us to replicate the results. Seed or random seed, something. Okay, so this seed value uh, tells us that what what a random number we should start with. If we don't specify it, it will select that random number automatically, and then it will dock with random numbers, and every time we will be getting different results. So what I'm to check this, I can change the config file, because in the config file I have already noted most of these value, like random seed I have already noted this down. I will delete it from here. So if I delete it, I will get different results for the same docking point. And by pressing up arrow, I can repeat that experiment again, and I'm going to save it as result 2, and I will see it will take some time, so I can check it later. So basically you have got the understanding of this table. Fine. So these are just a number of conformations of the ligand, and these are the affinities, means energies provided by the software, means they are not some direct random energies or a random calculations. These are means from algorithm, means if you see the documentation or guidance, here you will see what scoring function it is going to use to provide those results, that minus 6 value you were seeing. So it is basically going to use either AD4, VINA or Winardo, but we are not specifying any type of energy function. So by default it is going to use VINA, which has been described here. So while writing paper or demonstrating or explaining your results, you can mention that the software I was using for docking has been using VINA as a scoring function, and that scoring function has given us the energy of minus 6.186, and the unit of the result is kilocalorie per mole. So basically these few things help you understand to compare results from different software. So from here you have got one scoring function, meaning of scoring function, and you have already used these 6 parameters from the command line, and also I just explained seed value. Okay, so and this also one exhaustiveness is like by default it is going to provide you some 9 conformations, means 9 possibilities of a ligand, but you can change it, to 12, 10, 20, 100. So based on your requirement you can try to give it some exhaustiveness value. Sorry, I'm sorry, I have mistaken here. Exhaustiveness uh, exhaustiveness is means how many times it will try at a site. So basically it will try for 8 times for a particular site, like if there is a receptor, and if have to it is finding that it is a good site where it should try for a docking pose. So it will give 8 tries here, 8 tries, and some others it will select then other site and give another 8 tries. So basically this may controls the software to use resources optimally, and the option which controls the number of output, like here you are seeing 1 to 10, is this num modes. So I have said that num modes in my config file, which is 10, and you without defining this num mode you will get 9 results, which you all might be getting as till here, means 9 results you might be seeing in your docking results. So these options give the different results, and you can set them based on your needs, and by using default option is also okay. So now what we have got the output file. So this lig underscore out file is the docking results. Basically after docking you will get some files. First is docking score log, which you were seeing as a table, I have explained that. And next you will be getting output as molecules. So that molecule is saved as lig out dot pdbqt. You can control that name as well, lig underscore out dot pdbqt, by defining it using some parameter, this out parameter. So if I would have given it some name, it would have given me some different output file name. So basically I have explained the score file, score results, and a few more parameters, and I was explaining about the results replication which you can replicate using term seed. So if I change the seed parameter, the results might different, and also the output of the file. I will compare the result 1 and result 2 side by side so that you can see how seed value affects the results. So here you can clearly see here seed value was I guess seed value is not recorded here, maybe. Okay, so seed value is not recorded here. Okay, leave that. But I have okay, so sorry, it is recorded here. So here seed value was 411033, which I have randomly selected, and the next time seed value which was selected by AutoDock VINA, so it has randomly selected some seed value. Now here we can see that results are changed, means earlier those results were different, and conformers were bit away from each other, but this time the results are bit different. So by changing parameters we might get different results. And if you want to share something with others so that they can also get the same results, you need to copy this seed number which you have used in your results. So this will help them get same results in their docking part, where they will be using this all other parameters like scoring function and config file. If you share config file, they will get almost similar results, means these parameters you need to share to make them replicate your results. Now we have already out.pdbqt file, which we can check how these conformers have been resulted by docking procedure. So here I can use open Chimera X, which can help us visualize the docking results. I will repeat it as a complete set, because I am emphasizing one concept at one time, but it might be confusing to you. So after this analysis part means after hydrogen bonding and interactions part, I will create a simple story, so that simple story or a case study, so that it will be easy for you all to understand and relate what I have already explained. Because after that this whole thing will complete a docking protocol. I have not been able to open Chimera. Okay, so Chimera is here. Now to visualize docking results in Chimera, I might get some already result visualization, structure analysis, maybe. I forgot actually the name which visualizes VINA docking results. Okay, leave that. We can directly drag two results, means this lig out.pdbqt and receptor, so we can visualize them at once. Basically this was my receptor, and if I hide the receptor, these are the predicted poses. So and the original ligand was initially placed here. If I use original ligand, it is placed somewhere. Okay, it is very distantly placed. And if I, so this was my original ligand. Here you can see this is the original ligand and this is the receptor. But after docking these are the suggested conformers, means these are the suggested interactions of ligand which this drug might be interacting with this receptor. So I don't really need this. I just wanted to share that how ligand was moved by the docking software to check where it might interact. I will close leak.pdbkt now. So here we are seeing 10 poses. Fine. And to check results one by one, I can use one command, mseries, mseries, slider has and model id 2.1 to 10. So let me explain this command to you first. Okay, see the result how it looks. Fine. So I can if I means scroll this, it can tell show me one by one position of the ligand. Now I will break down the this command. I am using mseries, mseries, slider. Actually mseries provides series of the input, means there were 10 conformers and I want to see them one by one. So it will provide one by one, and by providing this slider option, it will provide a slider which you are seeing here. So I used mseries space slider, and then I used has 2. Has 2 means model 2, but we can see here, we can see here that there are sub models as well there. If I focus here, there are some model as 2.1, 2.2 and 2 till 2.10. So to define that, you have that it should cycle from 2.1 to 2.10. I have used command to complete command as mseries slider has 2.1 dash 10. So what it will do, it will start from 1 and move slide till 10. So using this command I am able to navigate. Just focus here that it will be switching this visualization, so I don't have to hide again and again. It will do it that automatically. And to clearly visualize it, I will change its representation here, and I can use this play option or use this record option to record this play and share with others. So like that it will play all and also it can record all. So I will stop it for now and change representation of the all the molecules. Basically I need to show all. I'm selecting all of the atoms, so I can change all the atoms representation here. So I am changing it to surface, and now if I use this slider or play option, I can change I can see changing position of all the ligands. So like that here these ligands are interacting at different sites. So this first pose is pose number 1, which we were seeing sorry, it's pose number 9. So this pose 1 2.1 model is interacting at this site, and this pose number 2 is interacting at this site. So first pose is interacting at this site, and second is interacting at this at another site of the receptor. So basically we need to analyze the receptor structure, where there might be some important domains. Like if we talk about cell surface receptor, the exposed domain, which are extracellular, might be receiving some atoms, and their residues might be interacting with some with drug or some other molecule, which if we provide some drug which might block those residues by interacting with them, then that interaction will not allow allow the original molecule to interact, and like that we can block the receptor. So that analysis part we will be connecting from your research paper, but let's first complete these few things which will help us to utilize the software. So like that other poses will be at different position. So just I am going to connect your these positions of the predicted bindings from your results. So if I choose this result dot log, then first pose is this, which is shown best by the docking software, and next second pose is this. So this means by interacting at this spot, it is having some energy, it is giving some score of -6.179, and at by interacting at this spot, it is giving some score of -6.186. Means both are almost similar, but first one is better. And among these RMSD values, these two these means first pose and second pose are like 36.25 Armstrong apart. So means the from their center, these two are some these distance apart. So by seeing this result, you can say that these two poses are apart from each other. I hope this much is understandable to you. I will just recall repeat these things what I have shared with you. First we performed VINA docking, and there we got result dot log file, where we got table, and in the table we got conformers and scores scores by using some scoring function. And here we have scoring function and VINA. Next we got out.pdbqt, means number of possible possible interacting conformers or possible poses. So we can simply call it poses. And then we can open receptor.pdbqt plus sorry receptor pdbqt plus out.pdbqt in chimera x, and there we can use M series slider option to navigate poses one by one. So this much was covered in today's session. I hope this much was clear to everyone. Basically, if you want to practice it right now, means it will take just 4 to 5 minutes. If you want to practice, I will wait. And if you want to ask any question, uh, you are welcome. And if you have any question, please feel free to ask.
Hello, sir.
Yes,
Sir, I shared my I was
you are sharing
playing.
your screen.
Yes, sir. I'm
Yeah,
sharing
please
my
share.
screen, but not sir. Where you last time I was performing before in front of you.
Yes.
Okay. And then sir, after that I was trying and the same thing, but you are. It is not. I'm not getting the answer, sir. Tell me, sir, where I doing incorrect. See.
Yes, please share your
Again, I
screen.
was doing. Yes, I shared my screen, sir.
Okay, so you can
See here, Vina dot exe, then the receptor, and then the ligand, and then the configuration text dot txt,
okay.
and then after that,
You are seeing the
these.
output, right? And you are getting some error, parse error in keyword unknown inappropriate tag. Fine. So if you can you open it in text notepad,
Uh,
QUAD4.pdbqt file.
yes, sir.
Have you
Sure.
converted it to pdbqt?
Yes, sir. I converted it PDPQT. Last time we were doing like I'm doing with like in front of you now.
Yes.
That time I was converted that part.
Okay, fine, fine. So can you show me the pdbqt file? I guess there are some problem in pdbqt file as it is telling us.
Okay, sir. See this two file I the this two file earlier I was doing with this one quad.pdbqt.
So
Okay,
from
I'm opening it with notepad. Not okay, notepad.
um, is it pdbqt file? Remark comparison from version 2.0. Can you open quad 4 file?
Yes, sir. Sure, sir.
You have not selected quad 4, so it won't show you option to open that.
Yes, sir.
Are you sure that it is pdbqt file?
Mm, but two file, there's two file, but they are like different.
No, actually, in the beginning, I shared that how you can compare two file and tell if
Uh,
what
so-
what file format are those two. So
yes, sir.
can you compare these two files?
But sir, definitely these two file are different. I think this is PDB file because PDB file. This is the format in the PDB format,
Yes,
file
that
format.
that is the possibility here. So have you tried docking with quad without means that actual pdbqt file, and was it
Uh,
successful?
so with the quad 4 and or only quad.
Only quad.
Okay, I was okay. I'm I'm performing in front of you this quad 4 file. Okay, sir. And then
Yes. Have you
I'm going.
haven't you tried it earlier?
Yes, sir. I tried earlier when I shared my screenshot with the that is in the Telegram.
Yes.
That time I was doing with the quad PDB
So
QT.
that
But
worked
after
fine. You
yes,
got the
sir.
result. You got the results for quad file, right?
No, no, I didn't get the result, sir.
Okay,
I
okay.
shared the screenshot. Okay, sir. I am doing in front of you. Okay, sir.
Sure, sure.
I think this one again I have to, but that's I copying, na sir. This one I have to
Yes,
copy.
you can copy and just right click it and it will work. Uh, what is the one quad.pdbqt atom type syntax t1 is not a valid autodoc 4 type. Autodoc type. How it has t1 file? Can you open quad.pdbqt? Is it a protein? Use Quad. Can you open it in Chimera X or some other visualization software so that I can see? I
Yes,
guess
sir.
it is a protein. Are you using protein?
This one is quadriplex 4. I think this one is protein, sir. It's yeah, it's a protein only.
Okay, so just understand one more thing, that this
Yes, sir.
AutoDock VINA is for protein, RNA, DNA, and ligand. Ligand means any small molecule which is not protein or DNA or RNA. So it is basically for receptor and ligand. So you for protein interaction or protein docking, we had different software. I will share them as well. But for now, you should choose some small molecule or ligand or some drug for the docking with AutoDock VINA. Okay.
Okay, sir.
Okay, so I will be sharing all other resources, but first to complete this part using some drug molecule.
I think should I change my this one receptor? Yes, sir. Should I
No,
change?
you should use same receptor which is protein, but for the ligand part you should use some drug. And have you removed heteroatom records from quad.pdbqt, means your receptor file? Okay, I guess I was confused. Means for quad.pdbqt it is your receptor, right? So inside your
Yes,
receptor
sir.
file there are some other type of residues which you should have removed. Means like they are not non-amino acid residues. So can you check them using notepad? Here
Yes, sir.
you will be seeing some heteroatom records which you should remove.
Yes, it has
Okay, you have
heteroatom.
heteroatom records, so I would suggest you to remove them and try again. So it will work. So select all the heteroatom records.
Cut.
Press Ctrl S and it will save. So you don't need that. Okay, so check if
I think
there are other heteroatoms as well using Control F.
this one, this
This
one
is
I have to
terminate.
remove, na sir?
No, don't remove that. That is termination record. Means that is terminating a chain. So
Okay,
let it
okay,
let it be there.
okay, sir.
Use Control F to find if there are other records. You can use Control Find option.
Control F and H atom. Yes, sir.
Yes. What was the name that which you have removed? HEATM, right?
HATM.
HET HET Hit. Only
HET.
just type HET.
HET.
Yes. Try finding it.
Yes, sir.
Okay, so like that you can navigate to hit atom record and see the what's the spelling of hit atom record
Yes,
name.
sir. Yes, sir.
Okay,
Exactly.
so
HET. Het.
remove all those records. That's why I instructed you to remove heteroatom records in beginning. Okay, so I guess you know now you know why you need to remove those records.
Sir.
Okay,
HET. ये क्या हुआ?
one more record should be there. Means uh, use Control F and find more.
क्या हुआ? I think I saved Control S.
Yeah, save that.
Okay. Now I am to again have to do this now.
Yes,
That is
just press
quad.
up arrow, press up arrow and wait
Uh,
before pressing enter. Okay, press up arrow.
press only up arrow, no?
Yes, up arrow.
Up arrow.
You are not pressing up arrow. You are using some other shortcut or buttons like Control Shift or Alt. Don't use that. Press up arrow only.
Up arrow means
Arrow,
which?
left, right, up, down.
Yes, sir.
Four arrow keys on your keyboard. Press up arrow key.
Yes.
Okay, so now type space,
Space.
angle bracket,
Angle bracket.
greater
Yes,
than,
sir.
space,
Hmm.
because
Space.
whatever output will be there, that will be saved to a file. So result.log or result.txt or vina.txt, whatever name you prefer, or you can also name it quad and your drug name to clearly identify it. Name it
Yes, sir.
whatever name you prefer for the output file.
Okay. QSTREP. Q strep. Quadruple and streptomycin. Dot
Dot txt.
txt. Now enter.
Yes, now enter. So whatever output you will be getting, it will be saved to. Okay, so you are still getting T1 is not a valid AutoDock type, means there are some other heteroatom records remaining in your quad file. Can you check that again?
Yes, sir. Control F. HT. Find
So in the
next.
last it's not finding, so you need to click on up direction, so it will try to find that out.
Yes, sir. Yes, sir. It is there.
Okay, so I would suggest to remove that as well.
Control F. Maybe. Now it is done. I think so, sir.
Yes, yes. Okay, now save it and try performing the docking. So it mostly it will be done.
Now again up arrow.
Yes, press enter.
Enter.
Okay, so step to it could not open. Step to means your file name and these are varying. So check what is the file name of strepto.pdbqt, exact file name in your directory.
Yes.
Okay,
It
so
is strepto.pdbqt.
check that it there are.
Yes, sir. It's a streptol. I wrote
Okay,
strepto,
okay, do
and in
correct
that I wrote
correct that,
strepto.
correct that.
Yes, it I wrote as strepto. So then I have to again up arrow and I
And
have to
use
change here.
left arrow to move to strepto.pdbqt. Then you can use delete or backspace to rename that.
I think it's TER. TER. Yes, sir.
Press enter.
Now,
Press enter directly, don't worry. So if it is working, it will you will be seeing good results. There you can see q strepto.txt in your folder, result folder, where you can open it right now and later close. In your result directory you will be seeing, yes,
yes,
this
sir.
this file. Check it out, what's the output. Okay, so it is performing and you will be seeing some results. So it is like 0% or something. So when it is, you close it now, and if you reopen, then it will be updated. Close, you
No,
should
sir.
close it.
Close it.
Yes, because by accident if you press Control S, then the current content will be saved, and you will
Okay, sir.
lose the progress. So I guess it is done because file size has increased to 2 KB.
Okay, sir.
Okay, check it once.
Now,
Okay, it will take time, but you will get the results as we were seeing. So now you can means remaining things you have already understood. So is there anyone else for the questions, or do you have any other question?
no, sir. I now I am done, sir. I got it.
Okay, I was expecting that you should have done it last time, but you didn't
Yes, sir.
update our.
Yes, sir. We didn't get the score at that time. It was almost 9 o'clock.
Okay, no
I
problem.
just okay, sir. Whatever you did in the today's class, I will try it. Next, I will change a different file with result.log and then visualize it in Chimera also.
Okay, okay. So Swami, who is
I think
there?
no one is here.
Sanjay is here. Sanjay, do you have any question?
Uh, no, sir, no, sir. I will just once again see this video back again.
Okay,
If I have doubt, I will ask Sunday, sir.
okay. Just try to perform a docking, and if you get some result, then
Yeah, yeah.
we will move
Actually,
to this.
like I have sent the assignment. I have tried
Yes,
with
I
the
know.
previous video I saw.
Okay.
Or I want to try in front of you. Is it?
No, no. Actually, he was having some problem, so I just asked him to perform before me.
Okay, okay,
If
okay.
you face some issue and not get result as expected, then you can I can guide you how you can do that.
No, 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 no. Right now, I whatever you taught me, like that way I've tried it. It came only once I had a issue. Like I didn't. I've saved like configuration, some like mistake with that. So
Okay,
I've somehow corrected it. Now I want to know how to interpret that result. So I will again go through this video and I will try. I'll see this.
okay. And actually, my main purpose was also including multiple ligand and receptor docking, which might be taking time because the people are not able to sync up to this much. So I will try to include that as well, uh,
Okay, sir.
because we can perform single docking, but there are times where we have to perform like 500 molecules or 1000
Um,
molecules. For that I will be also sharing all those most of the resources, so that you can
okay,
analyze and
okay.
interpret those results.
Okay, okay, sir. Then, sir, like, can
Yes.
you suggest any book regarding this docking, like how there are like still there are many options will be in this software. So, if there any book is there to go through to use this software one?
I would suggest you to go through the documentation. Means like if you are using VINA, it only performs receptor and ligand docking. So you should go through their documentation, and
Okay.
if they are providing some output, like they are using scoring function. So you need to know scoring, what is scoring, and then what is
Hmm.
the scoring function. And if they are telling you that they are using AD4 scoring function or VINA scoring function, you need to go
Mm-hmm.
through that algorithm or the formula of those functions you will be getting in their site or documentation, or
Oh, you.
mostly research paper. so
Okay, okay, okay.
so you will be getting those information from there, because books are mostly maybe outdated, because recently this AutoDock VINA was published in the year 2000, means 2022, latest. So books might not be updated or might be in process. So
So you're asking me to go through the manual which that software
yeah,
has.
manual or research papers
Research
basically,
paper. Okay.
because from the research paper you will be understanding how people are understanding the results from the particular software. And
Okay,
later
okay.
on, for protein docking and other molecule docking, you will be having different software, and they will be having different scoring function, but
Hmm,
basics
yeah,
will
yeah,
be
yeah.
same.
Okay, okay.
Okay, fine. So if anyone has any question, please feel free to ask. I guess there are no other people, and we can terminate the session now. Okay.
Hmm, okay, sir. We can.
Okay, good night.
Thanks.